Hello again. In this video, I will be trying to continue what I started with the previous one, which is how can we find the components of a vector by analyzing the vector into two components, the x or the horizontal component, also the y or the vertical component, and how we can calculate that. And I'll try to locate the angle in different places so we can tackle the question from different quadrants to help you to understand how we can find the components. Now, in this case, simply I have a 15 Newton vector. It's located with a 60 degrees with the horizontal. I'm asking you to find the x and y component of this vector. Now simply we can start with drawing. This is the, we can call it Fx as it's a Newton force, and the x component, and here will be the y component. Now following the what we did with the previous one or the previous video, well, I can close my triangle. That will be my Fy. So here, if I want to follow the trigonometries, I can tell that the cosine component, it will be going with the x-axis because it will be the adjacent. So I can say that Fx will be the magnitude of the original vector. Cosine 60 degrees, that will be 15 cosine 60, and we just do the math. That will give me 7.5 Newton. Now, to calculate the vertical component of the force or the y component, it will be, it's the opposite of the angle, which means the magnitude sine 60 degrees, 15 times sine 60. Again, that will give me 13 Newton. So these the component of the main vector of force. All right, that's the way to do it. It's very simple. You draw the triangle and you just look at which one is the adjacent, which one is the opposite, and then you can do the component. Let's try another example. This example here, the force vector is located in the quadrant 2, and I'll try to solve this problem here or this example in two different methods. First one, simply I will say, all right, that's the x component. Here is the y component. So this is, let's close our triangle. Once again, this is the y component of the force. Now, to calculate that, the x component, it will be, it's the, sorry, it's the adjacent of the angle, which means it will be taking the cosine of the 30 degrees. Here we go. That's the force. It's 120 cosine 30. Let's do the math. So and this will give me about 104 and Newton. But we have to be careful here. That's not fully accurate, because if we look to the x components of this vector, we can see the direction of it. And if you remember from the previous video, we said a vector quantity, it has a magnitude, which is the 104 Newton, and has a direction. And we can see the direction of this component going to the west or to the left or to the negative side, which means we have to put here a negative because it will be representing the direction of this component, because it's a vector. This component is a vector. It has to have a direction. That's one technique to remember, is the direction of your vector, the component of the vector. Or you need to remember that in quadrant 2, the cosine should be negative. So if you put in the calculator only 30 and you ignored or you forgot that you located in quadrant 2, it will give you a positive value, but it should be negative. Okay? Now, that's the x component. Now, to do the y component, it's the opposite, which means it will be the magnitude of the force multiplied with the sine 30 degrees. That's 120 sine 30. That will give me will give me 60 and 60 Newton. Now look at the direction of the y component. It's going upward or north, so it is a positive. And we know also in quadrant 2, the sine usually it's a positive value. Okay, as I said, I will solve this problem in two different ways. So let's try something different now. To avoid forgetting this sign, the minus or the positive, I forgot I'm located in quadrant 2. So to do this, I'll do this technique. I will assume that this is my angle, which is theta will be 150 degrees. So what I'm doing here, I'm saying the angle is located between the x-axis and the vector, which means the x component once again will be the adjacent, which means the force cosine 150 degrees. Now it will be 120 multiplied by cosine 150. And if you do that in your calculator and you put 150, the calculator know that you are located in quadrant 2, and it will give you a negative 104 Newton. Same. See? It will give you the exact value. Let's try the y component, which it will be based on this angle. It's the adjacent. So, sorry, it's going to be the opposite. Sorry, opposite. And sine 150. Here it will be 120 sine 150. Let's try it. Sine 150. And it will give me a perfect match to the previous technique. So which way you want to follow, it's fine, it's not a problem. But in the first one here, you need to remember in which quadrant you are dealing with your vector. That's one. The other thing, to alert you, to give you that, you need to look at the direction of your vector. Like here, it's going to the negative, so the x component must be negative. In case you forgot that you are located the sine and cosine, which one is going to be positive in which quadrant. Okay, so I hope you find this video useful, and I'll see you again with another one. Thank you.